Continuing our discussion of probability, in example 3, we're going to look at a contingency table. A contingency table simply means that the information has been broken apart into some subcategories that are rows and columns so that you can match up the people who fall in two categories at the same time. For example, an urban area and they drive alone. Okay, so what we're going to do is find the probability a randomly selected person was in an urban area from those who were surveyed. So a randomly selected person means out of all 564 of the people in the survey. Okay, and when you look, you can see again at the total, 313 people total lived in an urban area out of the 564. As a decimal, that is 0.555. Okay. All right, moving on. Find the probability a randomly selected person drove alone. Okay, well, again, out of those 564 total people, how many drove alone? Well, there's the 200 people that drove alone. As a decimal, 0.355. Okay, moving to part C. Find the probability a randomly selected person was from a rural area and carpooled. So a randomly selected person, so again, 565 is our sample size, but they were from a rural area and they carpooled. So that's these 85 people there, kind of in the crosshairs of the rural area and the carpool column there. That's those 85 people are the ones that are from a rural area and carpooled. So 0.151. Find the probability someone did not drive alone. Okay, they did not drive alone. So you have two options here. Okay, you can look at, there's 200 people that drove alone and there's 564 people total surveyed. So you can subtract 564 minus 200 to find out there were 364 people that carpooled or used public transportation. The other way you could do that, depending on your preference, is you could certainly add up the carpoolers and those who took public transportation. You would end up with the same 364 people. Again, it's just a matter of preference. Okay. All right, moving on to E. Find the probability a randomly selected person was in an urban area or took public transportation. All right, now here is that little word that I have warned you about and that we've been talking about, or. Okay, so the question is, they did one or, that means add, the other. Is it possible they did both? Can they live in an urban area and take public transportation at the same time? Absolutely. Okay, so as you do this, you have to be a little bit more careful. What you're gonna do is, I'm gonna get my highlighter here. A randomly selected person was in an urban area. So we know there are 313 people in that urban area. Also, we've got the or, so that means we're going to turn around and add. Okay, so or the person took public transportation. So this is the public transportation portion. Okay, there are a total of 206 people that took public transportation. However, let me grab a different color highlighter here. We'll try to get a little blue. Those 180 people right there were counted as both part of the urban area total and part of the public transportation total. Those are the people that were counted twice. So what we need to do is subtract off those 180 people, again, out of that total of 564, to find out that there were 339 individual people who qualified as urban area or public transportation, or both, and we come up with 0.601 as the probability. Okay, again, I'm going to erase all my highlighting. Oh, it's not going to let me erase my highlighting at the moment. Let me see if I can. There we go. All right, erase my highlighting. So we've got a fresh slate here for question F. Find the probability a randomly selected person drove alone or carpooled. Okay, drove alone, or carpooled. Notice there is no overlap in those categories. So there is no need, those are mutually exclusive events to use our terminology. There is no need to do any subtraction because there is no overlap. So that's 358 out of the 564 people for a total of 0.635. Okay, and then erasing again, last but not least, okay, find the probability a randomly selected person carpooled and took public transportation. So at the same time, like they had to do both, okay? There is no one who took public transportation and did carpooling, okay? All of those people would fall into one category. So this is one of those impossible events. The probability would be 0. All right, one more quick example that goes back to examples 2 and example 3. And these are, again, the idea of complement. So find the probability a customer did not get a phone at Verizon. So one of the things you may recall is the probability that they did buy their phone at Verizon was 0.29 or 29%. So 1 minus 0.29 or 0.71 would be the probability they're not getting their phone at Verizon. For those that carpooled, so the probability that they did carpool, there were 158 people out of the 564 that carpooled. And so if you do 1 minus 158 over 564, you end up with 0.720. Okay. One other note. So we've talked about unusual events, okay, what it means to be unusual. So we had one way in terms of being unusual, okay, we had more than 2 standard deviations. I'm going to say more than 2. I'm going to say 2 plus. 2 plus standard deviations from the mean. Okay, in terms of a box plot, we have Q1 minus 1.5 times the interquartile range, or Q3 plus 1.5 times the interquartile range. Those made things unusual, and again, it depended on what you knew, okay? In that first scenario, we knew the mean and the standard deviation. In the second scenario, we knew something about percentiles. Well, what if we don't know any of those? And so this is where this third one comes in here, or in general. We will consider an event to be unusual if the probability of E, the event, is less than 5% or 0.05. Okay, so this is, I know it's just kind of in bold and it looks like it's just thrown in there at the end, but this is actually some pretty important information, because throughout the rest of the course, you're going to be asked if this is an unusual event, and you're going to have to figure out if it's unusual, and you need to know all 3 of those, because depending on the information you've been given, usually only one of those ways is possible. Sometimes you can do 2 of them. But usually there's one that you have enough information to figure that out. So make a special note of that. It's one of those things that kind of gets overlooked in the class. People kind of skip over that. So highlight it, bold print it, put it in a box, whatever you need to do. And that is the end of section 4.2.